If we think about a wearable device that's using a fairly small battery, or even a single cell power source, you can imagine that the difference between a couple of millivolts over an hour and a couple of hundred or tens of microvolts over an hour might be of interest to the designer. It all gets into what the parameters you're trying to measure and how much accuracy and resolution and precision. And Keithley's really built a business for 70 plus years on helping customers understand and actually implement the necessary precision, accuracy, resolution, sensitivity, et cetera. Those are all different kind of words that test and measurement people understand the subtleties of. But that's kind of the world we live in, where we really try to make sure people understand if you're looking for a 0.1% answer, your equipment needs to be a lot better than that.
And that's exactly it. You could almost look at it in a military fashion. It's not good enough to have your weapons twice as good as the enemy's. It has to be 4 times as good as the enemy, because otherwise the benefit is not there. You're not getting the resolution you require.
We call that the test uncertainty ratio. So if you're after 1%, in a perfect world, all your tools would be 10 times better. In the practical world, 4 or 5 times is what you shoot for. But in the ideal world, you basically add a decimal, right?
Exactly, but then that's what engineering is, right? It's chasing the decimals in it, because the difference between a handyman knocking out a lamp in his household and, say, a luminaire designer is the luminaire designer's laying out and taking the measurements to be able to mass produce it, to reproduce the results. It's like a difference between a chef and a baker in their home. You can make something from the seat of your pants, but if you're cooking for 100 people, you're going to use a unit of measurement.
Sure. What you're saying is your degree of accuracy is very much a function of what you're trying to do. And if you're a casual hobbyist electronics person, 1 or 0.5% might be good enough for hobby work, but when you're seriously producing a product that you're going to mass produce in quantity, you're going to want to control the yields on it, you're going to want to have good customer experience. So when it comes to these batteries and our source meters, we often have to get into different wiring configurations. A lot of people don't understand remote sensing, for example, when the currents get large or the lead resistances get long. So we build those capabilities into our products. We have a relatively small, relatively sizable group of applications engineers around the world that help our customers understand all these subtleties and pick the right instruments for the job and then tailor those in how they're used. The only other thing I would throw out there, and Mark and I debated it a little bit, as we've gotten a little more intimate, let's say, with battery testing in the last year or two, for all the reasons we've described, I guess I'm a little surprised at how complex of a system that these batteries are actually. And when I say complex, I mean that they're an electrochemical little engine that generates electron potential, but they've got these interesting DC characteristics that we can do some interesting tests with. Charging and discharging is kind of the simple one. There's DC impedance tests that you can do using stepped currents and stepped voltages, and there's even some AC impedance applications, and there's even some frequency spectroscopy that can be done. So there's an interesting bunch of science around batteries that I didn't fully appreciate until the last couple of years we started really looking at it, and again, driven by this increased interest and use of these kind of cutting edge, lithium and various chemistries of modern batteries. So it's a pretty interesting space, and there's a lot to it, and maybe we can talk some more down the road about some other facets of it. But for the most part, the precision DC stuff is how we participate with our source meters and to some extent our power supplies and DMMs.
Excellent. Well, hey, Chuck, I want to thank you so much for taking the time again to come on the show, and we'll bring you back downstream and we'll talk some more about it, because we hadn't even touched on things like the Internet of Things or other aspects and other app spaces that really impact on it. So we're definitely going to need to have you back on the show.
We're definitely doing some kind of advanced development related to some of those other applications we can certainly talk about down the road. That'd be great.
Great. Excellent. And I'd like to thank everybody out there in the audience for taking the time to be with us. We wouldn't be here without you, so please tell your friends. This is Alex Pault for Pault on Power. Have a great day.